Now the idea is to try to derive the general formula or the general form of the bias theorem. As you can see here, this is the general form. What it said that the probability of AI with respect to B, conditional probability with B, is this one, which is the probability of B given AI times probability of AI divided by the sum of all the probability of B with a conditional probability with AJ times AJ. So how can we get to this form from the to the of the Bayes theorem of the general Bayes theorem? We have some assumptions. The first assumption, you can see it right over here, no zero probability. PAI and PB are not zero. And the second probability is the mutual exclusivity and exhaustiveness, which said that we have AI until AN. Those are the A's you can see here. And they all together are mutually exclusive, namely, if one occurs, that then the other can't occur. And they are exhaustiveness, namely, all together are all the sample space. Okay, so those two are the assumption we use. Now let's see how we can derive the general Bayes theorem formula you can see here. So we start with this. We start with the conditional probability. This is definition. The conditional probability of AI given B is defined as um, the intersection probability of A, I, and the B divided by the probability of B. This is a definition. Also, uh, now we can define the probability of B to be, by the law of total probability, to be the sum of the probability of intersection between B and AJ. Now we run on all AJs and we take all the sum of all this probability. Now you can use this one. Look, you can use this to get that. Why? Because look at this. I can say that maybe I will give you another way to see it. It will be better here. You can see that the probability of B given A is the probability of A intersection with B divided by the probability of A. Therefore, the probability of A times A intersection with B, you can take the PA to the left and get that one, right? I just took this A to the left, and you can take from this and take the B to the left and get that one. Therefore, we can say that this probability is just that one using the formula, right? I just took the divided by PAJ to the left and got the definition for PB intersection with AJ. So this what I can derive from this. This is written here, but it's not really, you can't read this. Okay, so we define what is the probability of B. We can insert this here, and we also can insert a, instead of this one, I can write that one. This is again by definition we just saw. We took the A to the up, and this is exactly what we just used. Therefore, we can write, instead of this, we wrote this. Instead, this one is just here. We can write this instead. Therefore, we define how the probability of B is, and we can put it here. And we defined how the probability of AI intersection with B is, so we can put it here. And this is the general form of the Bayes theorem. Now, maybe it would be much easier to see it in two variables and not all the variables, but I still wanted to show you the general form. Now, in two variables, in two probabilities, in two events, whatever you want to call it, it looks like this. This is the Bayes theorem, which is much more common to see. Now, how can we derive it? The definition for A given B is A intersection B divided by B. Probabilities, yes? And you can also say the probability of B given A looks like this. Again, definition. Now, you can move PA to here, you can move PB to here. Both will be intersection A and B, intersection A and B. Therefore, they are equal. Namely, take B to here, get this. Take A to here, get that. Now, both are the probability of intersection of A with B. Therefore, this side equals to that side. Therefore, I can write it like this. When I write it like this, I can take the A given B to here, and then the P of B can go down here. And here it is. And that's it. This is the Bayes theorem with two events. Now generalizing it, and we got to this form. But it's quite the same idea. Just here it says B, P of B, and here it's the same, and here it's the same, just we have I here, because it's for each AI event. Okay? So this is it. This is about the general form of the Bayes theorem. Thank you very much, and if there are any corrections or mistakes, please tell me and write it down.